Welcome. In this video, I'll talk about tests. I'll show you how to write unit tests and integration tests in Rust. The language has a few features which make this particularly easy. We start with a tiny example in which I have just a normal executable with a main function and some function, and I want to test this function. I just add a test function which is marked with the attribute test like this here, and I can put this, if I want, in the same module as the function. So the function doesn't have to be public, and I can just use the same module. I put in a few asserts, and that's it. If I run this program, I'll see nothing of the test function, but if I do cargo test, then it runs my test. Here's the test function. It says 1 test was okay, 0 failed, 0 were ignored, nothing was benchmarked, nothing was filtered out. Now, let me show you what happens if this test fails. If I just change the number here, then doing cargo test will show me that test with the name testf failed. It says the failure was that the left was not equal to the right. Left-hand side was 2, right-hand side was 3, and that happened in line 11 of the main.rs function. So hit the G, I go to line 11, I fix the result by changing the right-hand side, and I do another one cargo test, and all passes. Let me just mention that if you do cargo test, you can also add -- release, because if you don't do this, then you get a debug build. And if you do it with release, you get a release build of the test executable. Rust basically collects all the tests, creates an executable, and runs it for you. Sometimes you want to temporarily disable a test. If you want to do that, you can just put the ignore tag here, in which case the test will be ignored. So the testf is ignored, nothing has passed, one was ignored. And then, of course, if you want to still run tests with ignored, you just add -- and -- ignored here, and then the ignored test is actually run. Quite often, one puts the tests for a module into a submodule with name tests. In this case, you have to do the following. You do this annotation here, the configuration option test, for the module. And then, of course, if you want to access a function f, you have to use the super specifier, because the function f lives one module above the tests module. So therefore, you have to use super here. Here, for example, I use super f. Therefore, I can just use the function f as is here. This does exactly the same as we saw before. What is quite often the case is that you just simply import all the functions with this notation from the super module, and then you can just in your tests use the same functions as in the top level module here. Note that it's totally not necessary that the submodule tests is written in the same file. Exactly as for other modules, you can just declare the module here. You put the annotation here in the top in the main module, and then you store the code for the tests in a file tests.rs if the module is called tests. And here you use exactly what you would have used in line. Again, you mark your test functions with test, and you use the super trait here, so super notation here, because it's a super module. Works exactly as before. This example, I have added two functions, which I both call in the main function, and then I have added 2 tests for each of them. The point here is to demonstrate the following. If I just do cargo test, then it runs all the tests. If I give a name of a test as an argument, in this, for example, testf, then it runs only that test. That is, by giving an additional argument to cargo test, you can specify which test to run. Let me point out something about standard output. If one of your test functions actually prints something to standard out or standard error, for example, here I've added a print line statement, then if you run cargo test, this is normally not shown. So the output is suppressed. But you can add an option to the test executable. Note that this has to go after the two minuses here, otherwise it's an option for cargo. And you can say no capture. In this case, standard error and standard output are actually printed, and you can see the output of your test functions. That can be convenient at times. So far, we have talked about unit tests. Unit tests are best put close to the code, but sometimes you also want to do integration tests. For integration tests, you can add a tests directory. But notice that you cannot test functions from your main binary in an integration test. Therefore, I've changed the code here as follows. In the main thing, I just use the function f, but I call it like with this notation here with a crate name. So I import or I use testing : f. Note my project here is called testing. And this means that I have to put the source code for this function in the librs function. So here I've just copied the code over. This is a typical way how you can expose your functions to integration testing by essentially just making it so that the project is both a library and an executable. The main code has just very minimal stuff to build the executable, and all the functionality resides in functions which actually are a library. Note that I have here a public function f and a private function g, and such that the compiler doesn't complain, I call g from f here. I have both my unit tests here, just in a separate submodule, and now let's look at the integration test. The integration test lives in a file in the tests directory. I called it integration.rs. And what I do here is I again use just testing : f. The main project is called testing, which I can do because the integration tests have access to public functions in the libraries of the crate. Now, this here works. I could have done the same by just saying testing : f here, or if things are in submodules, then I have to put the submodule names here. If I run this, then I see that it first runs the unit tests, and if everything is okay, then it next runs the integration tests, running one test here. And here's also the doc tests. We cover this later when we talked about inline documentation. Anyway, the integration test is here run, and it has access to all the libraries of the project. That was it already for testing. As you can see, Rust and Cargo and the combination of the two have very powerful methods to make it easy to write tests in form of unit tests or integration tests for your software. Please add tests because this enhances the quality of your software. And this was it for today. See you in the next one.